Hi guys, welcome to today's Sunday contest. Today we'll be discussing problem number 3. So let's get started. Okay, so the problem says that um, yeah, you got some devices and their ratings, and what you're supposed to do with this is you can pick any one device, okay, which we have not used before, and then we remove exactly one unit from that device, and we just add that unit to any other device, and then we just mark that device as used. And every device also has a rating. The rating of the device is the minimum capacity of the units. So you have to do the operations such that after doing them, you return the maximum possible sum of the ratings of all the devices after any number of such operations. Okay, so pretty simple. So the example is pretty self-explanatory. Like you get 1 3 and 2 2. So let me write that down. Okay, 1 3 and 2 2. This is your device 1 D1, this is device 2 D2. Okay, so what you can do here is you can pick any one unit. Let's say you pick this one, and you can transfer it to this guy D2. So now after doing a transfer, it looks like this: 3 1 2 2. So what's the answer here? Your answer is 3 plus 1, which is 4. Okay, yeah, so that's how you can do this stuff. So I'll jump straight to the observation, okay, because that's what will help us move forward. So the observation here is that um, let's say you have got some array like this. Let's say you got 7 8 9 10. You got a single array 5, right? And then you got, let's say, 1 2 3 4. Okay, and then you got, let's say, I don't know, let's say you got 2 6 10 or something, right? Yeah, 2 6 10, and let's put an 8 here, 8 12 or something. Okay, dot 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 dot. Okay, so the observation here is that in order to increase our answer, we need to remove the minimum. Okay, and since you remove the minimum, you already have used that device. So our first observation, number 1, is always remove the minimum element. And why? Like, why should we remove the minimum element? Because because our answer would only increase if we remove the minimum, and that makes sense, right? So if you remove the minimum, let's say you remove 1, only then you get an 8, and only then you get an answer, you get a chance to add an 8 to your answer, right? Because the device rating is like the sum of the minimums. That's why, I mean, the answer is the sum of the minimums that you have to maximize. So that's the observation number 1, like always remove the minimum element. So what that brings me to is my second observation. We only care about first 2 elements of any device, first 2 units, I mean, or elements, whatever. Okay, that's because if you remove the minimum element, and then you have to transfer that minimum element to some other device, right? So you can put that over here, or you can put that here, or you can put that here. So what will happen if you remove the minimum element? Rest assured that, let's say your device, let's say you're planning to put in this device. Okay, I'm just taking a generic case. This is some device, and you're putting this minimum element, and you're putting an element E here. What can happen? Either E will come to the top, or E will come somewhere, it will go somewhere, right? or it can also happen a1, a2, e. Yeah, these are possible cases that we can get, right? So now this e, if you see, if you put here, then your minimum element is e. If you put in this fashion, it's still a1, and if you put in this fashion, it's still a1, right? So what I'm getting at is, again, we only care about the minimum element, right? And then let's say you try to remove a1 from here, you get an e. If you remove a1 from this case, you get a2, right? And from any other cases, a1, a2, a3, e, if you remove a1, you still get a2, right? So this is, I'm just proving my second observation, like we only care about the first two elements. Either it's a1 or it's a2, because in both cases you might get the minimum as a1 or a2 or e even. So e is again coming from some other array, so that's again the minimum of that array, right? a3 we don't care about at all. So now our problem reduces very significantly. Our problem now says that we only care about the first two elements of any device. So now let's do that. Let's try to reduce this giant device block into first two elements. So we got 1 5 1 8. We don't care about the rest. Let's put a dot 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 2 6 dot 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 7 8 dot dot dot. Okay. And now let's do one more thing. Let's do this. Like, it's always beneficial to remove all the minimums and redistribute them. So that brings me to my third observation. I'll just write it down. Always beneficial to remove minimums from all devices and redistribute them optimally. Okay, so I'm recording. Yeah. So this is because if you remove the minimum, then you're exposing the second minimum, and that increases your answer. So it's always better for us to remove all the minimums and then redistribute them optimally. So we will see how we'll redistribute them optimally. But let's execute our third observation now. So after doing the third observation, my first array will become empty. I'll just maintain a minimums list here, okay, which is 5. Then my second array would become 8. This would become 6. This would become 8 again. Okay, so now I've got 5 and then 1 and 2 and 7, because I removed this, I removed this, I removed this, I removed this. Okay. And now what I'm left with is the second minimums array. Let's call this smin's, second minimums. Now I have to redistribute them optimally such that my second minimums are preserved. Okay. So what I mean by that? So what I can do is I can sort my minimums, I can sort by second minimums. So this is empty array means 0, right? So after I sort my second minimums, I have this 0, 6, 8, 8 smin's. And after I sort my minimums, I have this. I have 1, 2, 5, 7. Okay, cool. And now comes the last observation. We want to redistribute the minimums optimally. So what can we do? So let's say we start from the end. Let's say we start from 7. Where can we put a 7? Can we put 7 here? If you put a 7 here, then our 8 would get disturbed, right? Because 8 was coming as the answer, but now it will no longer come as the answer. So it's always beneficial to put 7 where our second minimum either okay, that brings me to my fourth observation actually. Always beneficial to put element E somewhere where it either increases the answer or doesn't affect it. Okay, so I mean, obviously the order is like priority should be given to increasing the answer. So in this case, you might put 7 here in this place of 0, right? So let's do that. Let's put 7 over there. So now my array would look like this. 7 is here. Okay, basically I'm putting 7 here. Okay, let's move on. And now my second minimums is this array. You got 7 here. And now we have come to a 5. So for 5, where do we put the 5? We definitely want to put it in the position of the minimum second minimum. Okay, so after you have exhausted all the zeros, so there can be multiple zeros, right? There can be multiple zeros because there can be multiple one element arrays. So after you've done exhausting all of that possibility, what you can do is you can put the rest of them at the second minimum place. So all of them should be dumped over here on 6. And that is because of this statement. It's always beneficial to put, that is because what will happen now is that, okay, you got your second minimums looking like this, 6, 8, and 8, okay? And you are still left with processing these 3, 1, 2, 5, because 7 we already processed. So 5 should be put here, right? If you put it at 8, then your 8 is like getting decreased. I mean, putting it at 6 makes it decrease less compared to putting it at 8. So that means that you have to again resort your second minimums after you're done exhausting the zeros. So resort this would give you 6, 7, 8, 8, right? Like this. And then you can safely put a 5 here. And with the same observation, you can safely put a 2 here. Same observation, you safely put a 1 over here as well, without affecting the rest of the answers. Okay, because again, if you put 2 somewhere else, it will affect the rest of the answers and you are getting a less optimal answer. So after the optimal reshuffling, you get array like this: 1, 2, 5, 6, 7, 8, and 8. Okay, dot, 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 dot. Yeah. So that's your answer. The final answer is 1 plus 7 plus 8 plus 8. Okay, and there is no better answer because we have followed all the observations correctly. That's why. Yeah. So algorithm would like wise it would be like exhaust all zeros. Like first you would sort minimums and second minimums. Exhaust all zeros from second minimums by placing, like, what do you place? By placing the minimums from the end of the sorted array, and then after you're done exhausting all the zeros, resort the second minimums array, and then place all the remaining minimums in second minimums of 0, which was a 6 basically. So this is just a simple operation. It's like s-mins of 0 equals to s-mins of 0 comma mins of 0, and you just take the minimum of that. That's it, because you put a 1 at the end. The 1 is coming at the front, right? That's why. So you just do 6 equals to the minimum of 6 comma 1, I mean the first element. So that's 1. Yeah, so that's the intuition behind the problem. Let me show the code. So in the code, what I'm doing is I'm doing the same thing that I just talked about. Sort all the units, and then get the minimums, get the second minimums. The second minimums is that if the size is 1, then you just push back a 0. Okay, and then you sort both of them, and now we iterate on the minimums array from the back. Okay, and maintain a second pointer on the smins. Okay, so if that is 0, then you just replace it, and you just keep incrementing. Else, now you're exhausting all the zeros, like you're exhausted all zeros here. So that's why we resort this array, resort the second minimum, and then just replace the lowest second minimum with the minimum, like redistributed. Okay, just to preserve the optimality of the answer. And then you break, and then you just calculate the answer. Like add all the second minimums. Okay, so yeah, that's how it will work. Thank you guys for watching, and let me know if you have any doubts. Yeah.